All right, so let's check this out for fractions that do not have common denominators. Actually, I'm feeling sad here. I'm going to sneak in one little example. I meant to have it typed, but I don't. So remember, if we have, did I? Nope, I didn't. If we have something like 3 over 40, what do I want to do? Minus 2 over 25. And we want to add, we first have to find a common denominator. And hopefully by now we're getting kind of good at this and we can just look for common factors, but probably the original way you learned to do this was to go all the way down to a prime factorization. So in this case, we'd get 2 cubed times 5, and this one is 5 times 5. So our LCD needs to have the 2 cubed times 5, whatever's in the first fraction, you need all of it. And then we need to add to that list anything we're missing from the second fraction. So we need one more 5 to be able to make the second fraction. And then it's just a question of what is each one missing. So the first one is missing a 5. We'd multiply top and bottom by 5. The second one is missing 2 cubed and 8. So we'd multiply top and bottom by 8. So we're going to get 40 times 5. So 200 is our denominator. And on the top we'll have 15 minus 16 over 200. Avoid the temptation to go reducing them. Sometimes people do that. We want to use the common denominator before we try and simplify. So I get negative 1 over 200. Okay, so this is the process for numbers. Now we want to do the exact same thing, but with variables in the mix. And really, I think the only trickiness to worry about here is just that sometimes things are a little bit tricky to factor. So be very careful with your factoring or you're going to be way off. I'm on my slow eraser process here. Almost. Okay, so first example, 3 over 2z plus 9 over z cubed. We can't just count these up because the pieces aren't the same size, but we can think about what these factors are. This is a 2 times z, and this is a z times z times z. So to make my least common denominator, I'm just going to write down everything from the first fraction. It's a 2z. And then I'm only going to add what I don't already have. I already have 1z for the second denominator, but I'm going to need 2 more. So I do need a grand total of 3 in the denominator. And then we go back up top, equals, and we multiply by whatever we're missing. So the first one has the 2 and the z, but it needs the 2 more z's. The second one has the z cubed, but it needs the 2. So we end up with 3z squared over 2z cubed plus 18 over 2z cubed. Sorry, this 2 looks like a z. I don't like it. There we go. And then we can perform the operation. So the operation here was addition. That's the last thing happening. So we need to perform the addition. Finally, once we have the denominators matching up, we can do that. And then we always want to look and see if we think we can simplify our fraction. The only way to simplify a fraction is to factor and cancel. I could factor a 3 out of the top, but that won't cancel with anything in the bottom. I don't see any other way to factor the top, so I think I'm good on this one. I don't think I need to do anything else with it. Okay, let's go through one more. The second one, people are really tempted in this one to start building their LCD and say, I need a b, and I need a minus 3, and I need a 1. But that's not quite right because remember we're talking about factors. The LCD is a list of all the factors that you need to make up either denominator. So we need to get them factored first, and in this case there isn't any way to factor it, so we're just going to think about it as 1 times. So our factors are 1 and b minus 3 for the first one. We don't need to write down the b minus 3. To build the second one, we've already got the 1 mentally in there, but we don't have a b plus 1, so we need the entire thing. There's no way to, say, multiply the second one by -3 to make it work out. If you did that, your denominator would be -3b minus 3, which still doesn't quite match. So you actually need the entire b minus 3 and the entire b plus 1. So first step, my pen is not working again. Okay, maybe it died. Let me see if I can fix it really quick. Sorry for the delay. Otherwise, I'll cut. Oh, I did something. There we go. Okay, so we're going to go back up to the top, and we're going to say 2b over b minus 3 is missing a b plus 1. And we're going to say that 1 over b plus 1 is missing a b minus 3. And remember, there's some implied parentheses around any of these. Really, there's no reason to multiply out the denominator, so I don't care. You don't need to do it for me. WAMAP might want those multiplied out, so we'll do it without, and then I'll show you, because it's only one quick step, that you can do it with the denominator multiplied as well. So here, we're going to have to distribute through and say we have a 2b squared plus 2b. And then we're adding the 1 times b minus 3, and that's going to make up our new denominator, or I'm sorry, our new numerator. Our denominator is this. I certainly would not start multiplying it out now, because I do want to see if I can factor the top and cancel either one of those. So my next step would be, let's combine 2b squared plus 3b minus 3 over b minus 3, b plus 1. Okay, so 2b squared plus 3b minus 3. So I'm looking for, I don't have many choices. I need a 2b and a b, and then my only choices are either a 1 and a 3 or a 3 and a 1. And one of them gets to be negative, to get that -3. So if I do 1 and then 3, my outside is going to be 6b, my inside is going to be 1b. No matter where I put the minus sign, that's not going to add up to 3. If I do 3 and then 1, my outside will be 2b, my inside will be 3b. No matter where I put the minus sign, I'm not going to get a 3 out of that. So I think this is not factorable, and I can quit. If WAMAP is picking on you, you can multiply that denominator out, but again, I would never care for your denominator to get multiplied out. The reason we do the multiplying on the top is because the top is really a sum with some weird factors mixed in. So either fully factored or entirely written as a sum difference, and preferably not a weird combination of those two. So if we need to, we can say the bottom is b squared plus b minus 3b, and then minus 3. Don't go trying to cancel out those 3's at the end. Those are attached to everything else by subtraction. Division